So, look, good afternoon, everybody. Welcome to our virtual Monash Open Day, and especially thank you for joining us for our Faculty IT presentation around Learn, Grow and Succeed with a Bachelor of IT and Computer Science. So my name is Dr. Matt Butler. I'm the Deputy Dean of Education in the Faculty of IT. So I'm really thankful for all of you joining us here on this Saturday afternoon. Just a quick little bit of housekeeping. First of all, I'd like to begin by respectfully acknowledging that you ask that you acknowledge the Wurundjeri and Bunurong peoples of the Kulin Nation, who are the traditional owners and custodians of the land of which I'm presenting from, and I pay my respects to their elders past, present and emerging, and we wish the same across this whole country or for wherever you may be joining from. You can see the Q&A as part of this seminar. So what I ask is that you pop any questions that you have into that Q&A chat. What's going to happen is that I'll go through the presentation and then I'll leave the questions for the end of the session. But please pop your questions into the Q&A as you think of them. They'll be moderated behind the scenes and then they'll be given to me at the end of the presentation. So I'll start to work through them then. So that would be great. Any questions you've got, please pop them into the chat. A little bit of other housekeeping. You'll have noticed that we are recording today's session, so that's fantastic. You'll also notice that your mic is on mute. Now, you won't be able to unmute yourself due to the size of the session, because we've got lots of people joining us, and we just don't want to have multiple people talking at once. So any questions, again, just please pop them into the chat. We know that you're likely to have a bunch of questions around the impact of COVID-19 on our operations and things like that. It's a really extensive fact sheet that we've got that's on the website. So that's probably the best place to start for some information there. And finally, look, thank you for choosing to attend today's session. We're really pleased to have you all, and we trust that you're enjoying the presentation so far. And look, let's get stuck into my session. So, future in IT. I think it's a great place to start, just kind of giving a bit of the landscape around the IT industry and the current state of things. So here we can see some stats from 2019 around these employment projections for the next 5 years, as we move to 2024, 2025. You can see that the demand in lots of different domains inside of IT are really strong. You can see web development, you can see networks, you can see business systems analysts, database administrators, software developers, support and engineers, all experiencing really strong growth. And look, I think it probably goes without saying that in the current climate, if you reflect on kind of the last 6 months, so much stuff has been supported by technology and online that I think even these statistics could be underselling the current situation. So the IT industry is in such a strong state at the moment that I think it's a really exciting and lucrative place to be in. On that, you can see the 2020 Emerging Jobs Report. The graduate salary is around $64,000. Very, very strong for a graduate coming straight out of university. The number one job of 2020 as being kind of bandied around is AI specialist, and we'll talk a bit more about those kinds of roles as we move forward. Also important to note that the IT industry offers one of the highest salary averages in Australia at around $130,000 for a professional, and then the average salary being around 112, and that's from a job report in 2017. And again, the IT industry in such a strong position that we can only imagine that kind of is going to look a bit better. Now I want to talk a bit about IT at Monash, and I think it's important, before I just kind of rush into talking about the courses that we offer, a little bit about IT in Monash University and why I think we offer something really unique in terms of IT education. I want to start by saying that we're a dedicated faculty to information technology teaching and learning, which is quite unique across the country. What that means is that we can bring all of these different parts of IT together under kind of one banner and one faculty. One of the strengths of that is we're able to get world-renowned academics and researchers in information technology and have them together inside the one faculty. And what that means is, rather than IT being kind of taught in other parts, whether it's business or engineering or science or arts, we have them here in our faculty, and we can get to exploit or use that expertise across all of our programs. All of our programs are also accredited by the Australian Computer Science Society, our undergraduate programs, I should say, which is really important. What a institution like Monash can bring is the facilities and the resources to really innovate in our teaching. And I'll talk a bit about teaching spaces shortly, but that's one thing that Monash has really prided itself on, and we've been doing a lot over this last 6 months. I think the IT at Monash, second to none, is the industry experience opportunities that you can get. Our industry-based learning program, which I'll talk a little bit about later, is, I think, the envy of many institutions across the country. And also our capstone projects mean that your ability to apply your study in a kind of an industry context is really, really strong. We're also ranked in the top 100 in the world for computer science and information systems, which I think is really important as well. About the people that we've got in our faculty. So we've got 162 academics and 68 professional staff that support us. Again, those academics are across the breadth of IT. We've got around 5,500 undergraduate and postgraduate students and around 220 graduate research students, which I think shows you the strength of our programs, that we've got such strong undergraduate, postgraduate and postgraduate representation. We're about 27% domestic and about 73% international, and that international is represented from many, many countries across the world. And what's really great to see is that our representation by women in IT is very strong in the undergraduate and the postgraduate space. It's also important, before I launch into the different programs that we offer, just to kind of reflect a little bit on some of the other strengths that we have in terms of our faculty. So here on the slide, you can see a comment around big data and around artificial intelligence. They are two very in-demand aspects of the IT industry at the moment. So in terms of looking for IT professionals that have data science backgrounds or artificial intelligence backgrounds, that's just growing more and more by the day. So we have programs that support those, but we also have world-class academics and who are educators and researchers in this area. And I'd argue that we have one of the biggest and best data science AI groups that you can find anywhere in the world. Excuse me. What we've also got is that our faculty's got a real focus on taking our research and looking at our teaching and really thinking about the broader impact that can have across the world. So we've got this idea around IT for social good, and at Monash, we're really contributing to society through quite innovative research and education opportunities in around the social good area. Like, so for example, on the slide here, you can see one of them is around improving access for the vision impaired. That's my research work. So I work closely about looking at new technologies and how they can support people who are blind or have low vision. So it isn't just about kind of creating new and fun technologies for technology's sake. We're really looking to apply these technologies for ways that can improve the lives of people or support people in many other ways. I think it's important to talk about those research opportunities because they highlight the strength of the academics we've got, and also that informs the teaching that we do. As a group of 8 university, that means that we're a research-led university, and it's great that that inspires our teaching. Another thing that inspires our teaching a lot is the spaces that we have to teach in. So on this slide here, you can see it's the WOODSIDE Building for Technology and Design, which is a building that was just completed earlier this year and is ready for us to move into and start delivering our programs from. What's great about this space is that it takes what used to be the kind of traditional lecture, tutorial, lab learning activity kind of approach and really turns it on its head. It actually says, well, industry wants collaborators. It wants people who can work dynamically in teams and all of those kind of things. So we've created spaces that support that. You won't find just a big tiered lecture theatre in this space. What you'll find is large collaborative spaces for students and academic staff to work together to learn and to solve problems. And that's super exciting for me as a Deputy Dean Education, because what that does is it allows us to really transform our teaching for what the industry demands and what best suits our students. So I'll just skip through that, but the WOODSIDE building is there waiting for us for when we get onto campus. Look, so let me talk a bit about the courses that we offer as part of the Faculty of IT. So I'm talking about the undergraduate courses here. So we can look at a number of them. And so what we've got here is the overview, and you can see that we have a comprehensive, what's called a comprehensive degree, and that's our Bachelor of IT. We have a specialist degree, and that's our Bachelor of Computer Science. We have another part of that computer science degree, which is our Computer Science Advanced Honours degree. And we also have a Bachelor of Software Engineering. So let me talk about each of those, including the majors that you can see and the specializations. So the Bachelor of IT is a 3-year degree. Its interest ATAR was around 80 last year. What a comprehensive degree like the Bachelor of IT does is it's a degree where you do a common set of units, so a common core, then you'll choose a major. So every student who undertakes the Bachelor of IT needs to complete with a major. And you can see the 5 majors that we have as part of this degree on your screen there as well. So we have a Bachelor of Business Information Systems major, a Computers, Networks and Security major, Games Development, Interactive Media, and Software Development. I think, as you can see by these majors, the Bachelor of IT is a degree where it's very applied, it's very hands-on, it's about taking technology and applying it in a very particular context, whether it's business systems or networks or games or software dev. So, and that's represented by the career outcomes you can also see on the bottom of the screen. So every student chooses at least one major, or you could actually choose to do a second major, or you actually have a set of 8 electives that you could do. So you might choose to do some study from another part of our faculty, so from computer science, for example, or software engineering, or you might choose to augment those electives with study from another faculty. And I'll also talk about double degrees shortly as well. There's a number of minors that you can do as well, and this is one part of the great flexibility about something like a Bachelor of IT, but also a real strength of a faculty, a dedicated faculty of IT. What it means is that if you're interested in a few different parts of IT, we have them all here for you. So you can see the gamut from things that are very technical, like cybersecurity, data science, computer science, through to the more creative side of things around games design, games development, and interactive media. And then you can have things like mobile apps development, IT for business, and the like. So again, I think it's one of the strengths of IT at Monash is the breadth of study that you can do within this one faculty. We also have a Bachelor of Computer Science. Now, computer science is what's called a specialist degree. Now, it's also a 3-year degree. It has an ATAR of around 85 to 86 last year. And what it is, specialist degree is you'll do foundation computer science study, and then you have the ability to choose a specialization depending on kind of what aspects of computer science you're most interested in. So it could be the more advanced sides of things, so more detailed algorithmic design and problem solving, or you may choose to focus on the data science side of things. I've already mentioned data science as a really emerging topic and an area in the industry. And you can see some of the career outcomes there. So they differ a little bit around a specialist programmer or researcher, as I said, technical analysts, through to data scientists who work with big data and try to understand data and support organizations in that. We have a Bachelor of Computer Science Advanced. So where that differs is it's based a lot on the computer science program, but it's actually a 4-year degree. As you can see, it's a very high ATAR of 95. The idea behind this is it's a research-focused degree. It's got greater challenge. It has more advanced classes. It introduces you to research and development throughout your degree. So what this does is really set, if you are keen for computer science, but you've got an eye on research, or if you're really quite a high achiever, we want to bring you into this program with like-minded peers, and where you can actually really start to develop some really deep critical thinking and practice around computer science. In all of our degrees, there's also around placements, that option as well. And the great thing about Computer Science Advanced is choosing to do a 6-month placement either in industry-based learning or in a research project. There's also the Bachelor of Software Engineering, which is a dual accreditation degree with engineering and the Australian Computer Society. So again, another 4-year degree with an ATAR of around 93. Now, this is run as part in conjunction with the Faculty of Engineering, where you would do a common first year of engineering and then branch out into software engineering specifics that are taught by academics from the Faculty of IT. Now, you can see some of the career outcomes here around software developers, software engineers. I might take this opportunity to kind of, I use a bit of a metaphor about how to differentiate between computer science, software engineering, and Bachelor of IT, because it's a common question that I'm asked. Now, this is a pretty crude example, but let's take Google Maps, for example, something that most people are pretty familiar with. So I think this compartmentalizes these quite nicely. So imagine Google Maps. It's a big critical system that spans the globe. It has to support millions of concurrent users. That's a real software engineering challenge. How do you design the architecture for that system so that it's across the globe, across multiple platforms, has to support millions of users? That's a real software engineering and software architecture problem to solve. Now think about what Google Maps does. Google Maps has got to get you from A to B. So I want to get from home and I want to get to work. You know, if I pop that in, that's a computer science problem to solve. There's a lot of algorithmic problems that need to be thrashed out there to work out what's the most optimal route to get you from A to B, given all of the constraints around traffic and tolls and all of those kinds of things. So there's a lot of algorithmic problem solving, which is very computer science domain. Then if you think about how you use Google Maps, you might use it on your phone, it might be as part of your car dashboard, it might be on the web. That's very much a Bachelor of IT problem to solve, which is around the interface design, the actual kind of end user experience, how you develop it for the web, how you develop it for mobile. So as you can see, that's the very kind of applied part of it. So it's a pretty crude example, but hopefully it gives you a bit of a sense of how these three areas in IT differ. What you can see on the screen now is a lot of the double degree combinations that we have. And as you can see down the left-hand side, we've got all of our different computer science, IT, and the majors there, as well as computer science, advanced and software engineering. And you can see the other parts of the university that we have double degrees with: arts, business, commerce, criminology, design, engineering, law, science. You can see we're very well represented across the whole university. So almost any other kind of discipline that you would want to pair your IT degree with, there are opportunities here for you as well. How long that double degree is depends on the length of those two degrees. If you were to do, say, a Bachelor of IT, which is a 3-year degree, and a Bachelor of Arts, which is also a 3-year degree, you use your electives from both to support each other, and you can actually get a double degree in 4 years. Some of these other programs take a bit longer, depending on whether you're starting with a 4-year base program or not. But as you can see, possibilities are almost endless. Some of the great advantages you get to coming to the Faculty of IT at Monash. I've touched on our industry-based learning program, but I would say it's second to none. We place hundreds of students in a competitive industry-based learning program, where if your grades are doing well, you can apply for it, go through interview processes, and then hopefully get a paid scholarship into an industry placement. Even if you don't make that, we also have really strong industry experience capstone projects that are part of all of these programs I've just talked about. The other things that you can see there on the screen are a number of faculty or Monash initiatives around how you can engage with your discipline in ways that are just outside of the subjects that you study. The industry team initiative, peer mentor programs, entrepreneurship programs, study abroad. As I said, the advantage of being in a university like Monash and a faculty like ours. So lots of opportunities for you. I talked about our IBL program. If you've got a 65 plus average, you're eligible. It's a 6-month full-time placement with an 18 grand scholarship. What's really great to see is you can see a lot of our industry-based partners there on the right-hand side. You can see the banks, you can see Deloitte, KPMG, Telstra, really strong employers of our graduates. And I would say it's a proven competitive advantage in the workplace. If you can get a spot in an IBL, then it leads to really strong graduate outcomes. Plenty of clubs and societies across the faculty. So I always encourage our students, don't just study. You've also got to get engaged with your peers in all of these other things that are interesting. And it could be around gaming, it could be about diverse IT, it could be around cybersecurity and networks. We've got some clubs and societies for you as well. Here's the entry requirements for our programs. I've talked a bit about the ATAR scores already. It's important to point out that the mathematics is the biggest differentiator in terms of the subjects. So for the Bachelor of IT, the maths requirements are a little bit lower, and then they ramp up for computer science advanced, software engineering. That's because the nature of the content in computer science and software engineering does have more mathematical requirements. So we do have those entry requirements for those programs. Probably just to almost finish off, it's important for us to reflect on how we've adapted in 2020. 2020 has been a crazy year. We had to transition to online really quickly. Luckily for us, we'd already started to do a lot of work in flipping our teaching and moving to blended types of delivery. We'd been live streaming and recording our lectures for many, many years. We'd already been using fairly extensively industry standard kind of virtual team environments for engagement and teamwork, those kinds of things. We already had a very strong peer mentorship program, and we'd already been running coding boot camps and those kinds of things. So what we've done is really ramp that up over the last 6 months. And one of the big questions we get is, what's in the future? Well, who knows? But what we do know is we're going to be learning from all of this, and we're going to be taking the best bits from here and making sure that they're part of our practice moving forward. Look, so that's a really quick go through our courses. I think it's probably important to get to some questions. So look, thank you for coming along. You can see here about following Monash Infotech on Facebook and Twitter. What I'm going to do is I'm going to get to some of the questions in the Q&A now. So they'll be kind of fed through to me, and I hope I can address all of your questions. So first question that's come through is around the background knowledge in IT that you need before beginning the course. I would say the most important thing you need is an interest in IT. It's not about having a lot of background programming or anything like that. Our first year kind of core units and foundation units don't expect that you've done any programming or anything like that before. We get you in as long as you've got a passion for IT and really want to study it. That's what's important. Those of you that haven't been engaged with IT, we've got plenty of boot camps and other thing and programming support that we can bring in. But no, you don't have to have any IT background. What we say is bring your interest and your passion, and that's what's important to us. So I've got the next question here, which is around differentiating between the major of computer networks and security and computer science. So that's a really good question. So if I use my example from before around differentiating between computer science and Bachelor of IT, what I would say is the computers, networks and security part of the Bachelor of IT, it's a bit more of the applied side. So you would learn around the practicalities of networks, supporting networks, looking after the security of networks and things like that. If you were to do the Bachelor of Computer Science, you would be a little bit more at the theoretical end of how that works. You would also get a bit more into the depth of the crypto side of things and theoretically how those things work. It's not to say you don't do it at a practical level, but one is a bit more at the theoretical side, one's a bit more at the practical side. For those of you who kind of then don't know which way should I go, what's important to point out is I often say, well, if you think you've got a head for mathematics and things like that, I think it's worth jumping into computer science, because what you can do is the 8 units that are part of the computers, networks and security major, you can do as your electives in the computer science. So computer science degree already covers a couple of those units, but you can then grab the rest of those units and do it as part of your electives within the computer science degree. So I think that's actually kind of the best of both worlds. But it again just depends on whether you want to get your hands dirty with the kind of applied side of things, or you want to be a bit more at the theoretical side of things. Next question I've got is around programming and its role in the data science specialization. So programming is strong through all of our programs. It's certainly a strong part of our computer science program. So in computer science, you will typically start with Python, and that's a pretty fundamental language for things like data science. When you get into the data science specialization, you'll start looking at applying things like Python. You'll also look at languages like R, which are industry level languages that you use for working with big data sets. So where I talk about programming, is it a big part of data science? It's definitely an important part. Data science also gets you thinking around the nature of data, how you work with big data sets, what analysis strategies and tools do you use to make sense of that data and be able to apply it for how an organization uses it. So programming is a part of it. It's not the be all and end all, but you will come out as a pretty strong programmer as a consequence. Next question is around the difference between a major in computers, networks and security and a minor. Great question. It's probably something I breezed over pretty quickly. So a major is a set of 8 subjects that you do in a topic area. So you get really in depth. A minor is only 4 subjects. So a minor gives you a bit of a taster, and it might give you a bit of background. So if we use that example about computers, networks and security and cybersecurity, computers, networks and security obviously is probably broader than just cybersecurity, which is why it has 8 subjects dedicated to it. Cybersecurity, however, we've kind of got a set of 4 units that really can get you up to speed and starting to get you industry ready to dive into cybersecurity issues. So that's the difference between majors and minors. In the Bachelor of IT, you have to undertake at least 1 major. But across all of our programs, you also have the elective space to choose minors, and that's where you might say, well, I'm doing a major in software development, but cybersecurity is really important, so I might go and do a minor in that as well. So next question I've got is, how do I find out more about the double degrees for IT? And the second part of that question is there a big jump in the workload of a double degree compared to a single degree? So what I would say is that I showed up that grid before that talked about our different double degree options. Best thing to do is to jump on the resources that we've got here in our virtual fairs to look at the information about each of those double degrees, as well as the Monash website, and really look at what those pairings are. With regard to workload, no, the workload doesn't necessarily jump. So a typical student load each semester would be 4 subjects. And that doesn't change if you're doing a single or a double degree. What changes is the length of your degree. So when I used that example before about a Bachelor of IT doing that with a Bachelor of Arts, so each of those is a 3-year degree, but you put them together using your electives, and you actually get to do a 4-year, you get to do 2 degrees in 4 years. It's not because you do more subjects each semester. It's actually because you kind of use your electives from one to kind of support the other. So you actually end up just doing 4 years worth of subjects under normal load rather than more subjects. So where it gets a bit hard is you're obviously straddling a couple of different domains. So you might have your IT hat on one day, and you might be studying something in business or arts or art design the next day. That's where a bit of the challenge comes through. But I actually think it's really rewarding to think about each of your degree programs in the context of the other thing. And I think it makes you a really versatile and employable graduate. Next question I've got here is around the differences between computer science and software engineering. So I talked a little bit about that analogy before to try and talk about what differentiates them at kind of a high level, but at a bit more of a practical level. Software engineering is part of our Bachelor of Engineering. So what it means is that in your first year, you will do a set of engineering core units before you branch out into dedicated software engineering units. Now, I'm an engineer by background. That's actually how I studied, and I ended up in IT. So look, the nature of the software engineering units are a lot around system architecture, those designing big systems with all of those other kind of constraints and things that you've got. Computer science, on the other hand, is a lot more around the fundamentals of how computers work and how they think and how that then gets applied. So, for example, I talked about algorithms before. So algorithmic problem solving and algorithmic design is a big part of computer science, because that's kind of the logic of how computers think and work and solve problems. So in computer science, you are more focused on that side of things, whereas software engineering, you tend to be more focused on computer architecture, computer systems design, understanding the requirements of what this system might need and how you translate that into an IT solution. So that's a bit of the difference between those two programs. I've got another question here, which is around the difference between capstone units available within the Bachelor of IT. So it's quite astute. So whoever asked that question, I think you've been doing a bit of your homework. So which capstone you do in the Bachelor of IT really depends on which major you choose. So we have two separate types of capstone units within that degree. For computers, networks and security, software development and business information systems, you will do our kind of industry-based capstone unit, where you will work with industry clients to solve industry problems. You'll use, because you'll have students from different majors, you each bring in your own expertise to come up with really quite holistic solutions to that. The capstone for games and interactive media, because those two majors are a lot around the creative end of IT, and so games development and things like that, you don't tend to do them for a client, but what you'll do is you'll create a creative endeavor. So it'll be a game, for example, that you'll work in a team and you'll be informed by best industry practice, but you won't be doing it explicitly for a client per se. It'll be a bit more of a creative endeavor based on the group that you've got. So that's a little bit of a difference between the capstone units, but what's important is they're both very much informed by best industry practice and getting you industry ready. Next question is around, do you learn around AI in computer science as well? So obviously AI has been a more emerging area. Indeed, we launched a Master of AI just this year as well. So, but our computer science program is definitely is informed by AI as well. We've had AI units actually in our computer science program for many years, actually. And that's only strengthening with each iteration of our computer science program. So you definitely do get exposed to AI in the Bachelor of Computer Science. And I would say that if you do have an interest in AI, then the Bachelor of Computer Science is the best place to start, probably more so than a Bachelor of IT. And look, I think that's coming to the end of the questions that are popping up for me, and we have gone a little bit over time as well, but there've been some great questions that you've asked. So look, if there's no more questions that pop up into my chat, look, thank you for coming along to our presentation. I understand that it was a real whirlwind through our programs. This is designed to give you a bit of a taster, a bit of an idea about what we offer, and I really encourage you to spend more of your time today to get more information about each of these programs. So for example, we have virtual booths for computer science, for our majors in the Bachelor of IT, in software engineering. Please go, the people that are manning those virtual booths and the chats in there, academics who teach into those areas and students who are our current and graduated students in those areas. What I encourage you is to pick their brain with all kinds of questions and really try to build up what you think you need to know to make an informed decision around what you choose. As I mentioned, I think it's the flexibility that we offer here in the Faculty of IT at Monash University that's a real strength, and that you could get into computer science, but you could support it with subjects from those other majors that I talked about. So thank you very much for attending. It's really appreciated. Please take care of yourselves and each other. And if you have any questions, please reach out to our faculty staff today or any other time afterwards. So thank you, everybody.